Struggling with hypothesis testing?
Or confused about population proportion problems?
Relax, we'll make it simple.
Today, we're solving problems involving test of hypothesis on population proportion problems.
What are we waiting for? Let's get started.
Hi guys, welcome back to our channel. For today's video, we are going to talk about test of hypothesis on population proportion. If you are having a hard time with this topic or feeling confused about how to solve it, don't worry. We'll solve it step by step so it will be easier to understand. First, what is hypothesis testing? Hypothesis testing is a statistical method used to decide if there is enough evidence to support or to reject a claim about a population. It helps us answer questions like, is the claim presented true? Did something increase or decrease? Is there enough evidence to support the claim? And etc. So our key terms, first, population proportion. This is the claim or true proportion. It represents the percentage of whole population. For example, a school claims that 60% of students pass the exam, so our population proportion is 60%. So we need to divide it into 100 to get the 0.60, the final answer. Next, sample proportion. This is the proportion calculated from the sample only. For example, you surveyed 50 students and 35 passed. So our sample proportion is 0.70 because 70% of 50 is 35. Next, null hypothesis or our H sub O. This is the original claim. It usually shows that there is no change or no difference. Number 4, alternative hypothesis or our H sub 1 or H sub A. This shows that there is a difference, change, or effect. Next, level of significance. The level of significance is the risk of rejecting the null hypothesis even if it is true. Test statistics or our Z. The Z statistics measure how far the sample proportion is from the population proportion. Critical value. The critical value is the boundary used to decide whether we reject the null hypothesis or we accept it or not reject it. Next, 5 steps in solving test of hypothesis or population proportion. Step 1, state the null and alternative hypothesis. So in null, we only use equal sign. And alternative, we use less than, greater than, or not equal. Step 2, choose the level of significance. So as I said earlier, that our level of significance. So step 3, compute the test statistic or our Z. So this is the formula we use to solve the test statistics. Step 4, find the critical value or p-value. So to find the critical value or p-value, we use this level of significance. The total will be this one, same as the other number. Step 5, make a decision. Your decision will be either reject the null hypothesis or fail to reject the null hypothesis. Next, our decision rules. If the computed Z value is greater than the positive critical value or less than the negative critical value, we reject the null hypothesis, and this is two-tailed test. If the computed Z value is inside the critical region, we reject the null hypothesis. This is a right-tailed test. Next, if the computed Z value is not inside the rejection region, we fail or we accept it.
Example number 1. A sample of 120 students was randomly selected from Masayahin High School, and 21 of them said they are left-handed. So we are asked to test the hypothesis that less than 22% of the students are left-handed using a 0.05 level of significance. So first, State the null and alternative hypothesis. Since the claim is less than 22%, this will be our alternative hypothesis. In hypothesis testing, the null hypothesis always contains equality. So our null hypothesis, population proportion is equal 0.22. And our alternative hypothesis, population proportion is less than 0.22. So next is identify the level of significance. So the level of significance is given as alpha equals 0.05. So next is compute the test statistic. Now let's identify the given values. So the sample size, which is the n, is 120. So the number of left-handed student, which is the x, is 21. So the population proportion is 0.22. First, we compute the sample proportion. Sample proportion equals x divided by n. So that is 21 divided by 120. So our sample proportion is 0.175. So next, we compute the z-test statistic. Using the formula, z equals sample proportion minus population proportion divided by the square root of p times 1 minus p divided by n. After substituting all the values and solving, we get z equals negative 1.190. So now, let's find the critical value. Since this is a left-tailed test with the 0.05 level of significance, we look at the z-table. So the critical value for a left-tailed test at 0.05 is negative 1.645. So this critical value is the boundary between the rejection region and the non-rejection region because this is a left-tailed test. So the rejection region is on the left side of the graph. So for our decision, let's compare the computed value and the critical value. So since the computed test statistic, which is negative 1.190, is greater than the critical value, or it falls in the acceptance region, so we fail to reject the null hypothesis. So our final conclusion, therefore, we conclude that 0.05 level of significance, there is enough evidence that less than 22% of the students are left-handed. Now, let's move on to example number 2. So a politician claims that she will receive 60% of the votes in the upcoming election from a random sample of 200 voters. 100 said they will surely vote for her. So we are asked to test the politician's assertion at the 0.05 level of significance. Now, let's state the null and alternative hypothesis. Since the politician claims that she will receive 60% of the votes, this claim contains equality. So therefore, this will be our null hypothesis. So we have null hypothesis, population proportion is equal to 0.60. And our alternative hypothesis, population proportion is not equal to 0.60. Because the alternative hypothesis uses not equal to, this is a two-tailed test. So next, identify the level of significance. So the level of significance is given as alpha equals 0.05. So now, let's compute the test statistic. Now let's identify the given values first. So the sample size, which is the n, is 200. So the number of voters who will vote for her, which is the x, is 100. So the population proportion is 0.60. So first, let's compute the sample proportion. Sample proportion equals x divided by n. So that is 100 divided by 200. So our sample proportion is equal to 0.5. So next, we compute the z-test statistic. Using the formula, z equals sample proportion minus population proportion divided by the square root of p times 1 minus p divided by n. So let's just substitute the given data. So we get z equals negative 2.887. So let's find the critical value. Since this is a two-tailed test with a 0.05 level of significance, we divide alpha by 2. So 0.05 divided by 2 equals 0.025. From the z-table, the critical values are negative 1.960 and positive 1960. These are the boundaries of the rejection regions on both sides of the graph. So our decision, since the computed test statistic, which is negative 2.887, is less than the critical value or it falls in the rejection region, so we reject the null hypothesis. So our final conclusion, therefore, we conclude that 0.05 level of significance, there is enough evidence that the politician will receive 60% of the votes in the upcoming election. Example number 3, our research states that 28% of college degrees are from engineering courses. A researcher does not believe that this is correct. So a sample of 500 graduates was used and it was found out that 95 have finished engineering courses. Test the claim if it does increase at alpha 0.10 level. Now let's state the null alternative hypothesis. So we have null hypothesis, population proportion is equal to 0.28, and our alternative hypothesis, population proportion is greater than 0.28. Because we use greater than, this is a one-tailed test, specifically a right-tailed test. So now, let's identify the level of significance. So the level of significance is given as alpha equals 0.10. So let's compute the test statistic. So let's identify the given values first. So the sample size, which is the n, is 500. And the number of engineering graduates, which is the x, is 95. And the population proportion is 0.28. So let's first compute the sample proportion. So that is 95 divided by 500. So our sample proportion is 0.19. So next, we compute the z-test statistic using the formula z equals sample proportion minus population proportion divided by the square root of p times 1 minus p divided by n. So we just substitute the given data. So we get c equals negative 4.482. Let's find the critical value. Since this is a right-tailed test with 0.10 level of significance, we look at the z-table. The critical value for a right-tailed test at alpha equals 0.10 is 1.28. This value is the boundary between the rejection region and the non-rejection region. And since this is a right-tailed test, the rejection region is on the right side of the graph. So our decision, since the computed test statistic, which is negative 4.482, is less than the critical value or it falls in the acceptance region, so we fail to reject the null hypothesis. So our final conclusion, therefore, we conclude that 0.10 level of significance, there is not enough evidence that the college graduates who have finished engineering courses has increased to 28%.
That's how you solve problems involving tests of hypothesis on population proportion.
Once you follow the steps correctly, everything becomes clear and manageable.
If this video helps you understand hypothesis testing better,
Don't forget to like, share,
and subscribe to our channel